Okay, so we've got a product rule here. So derivative of the first, e to the 2x, is 2e to the 2x times the second, cos of half x, plus derivative of the second. So the derivative of cos a half is negative a half sine. So there's the negative a half sine a half x times the first function, which is e to the 2x. Look, that's an acceptable answer, but maybe we should really tidy up a fraction. So if we just take the e to the 2x out the front, that'll give us the 2. I was trying to work out where the 2 come from. So that 2 slides back in there. So 2 cos a half x minus a half sine a half x, making sure we've got brackets around the whole thing. Yeah. And then a standard part B of that is to evaluate a derivative at a point. So natural log of sine x, so if I put u equal to sine x, du dx, derivative of sine x is cos x, and the derivative of log u is 1 on u. And then we'll just substitute our pi on 3 in. So cos of pi on 3 is a half. Sine of pi on 3 is root 3 on 2. That definitely needs to be tidied up. You can't leave a fraction on a fraction. So flip the bottom one upside down and multiply, and we get a 1 on root 3. That's perfectly valid. You don't have to rationalize. An antiderivative of cos 1 minus x. So the antiderivative of cos is positive sine, isn't it? I guess the k value here is -1, so it's going to be -1 sine 1 minus x plus some constant c. All right, so a little bit of negative sign in there that you've got to deal with. The fact that it's written a little bit differently. I guess if we'd have written it as cos of -x plus 1, it's really obvious, isn't it? But the k value is just -1. What else have we got? Evaluate this integral. So again, I'm a fan, as you know. Just write it as the integral of 3x squared plus 4x to the minus 2 dx. That way it's obvious when you add and subtract your powers. So if we add the derivative of 3x squared, add 1 to the power, divide by 3, gives me just the x cubed. 4x to the minus 2, add 1 to the power, which is -1, divide by -1, gives me a negative. 4 on x to the 1, substitute my 2 and 1 in. So I get 8 minus 2, subtract in brackets 1 minus 4. So again, just be careful with negative signs. We end up with +9. Again, another nice little integration one here. We've got to find the original function for the derivative. So f of x is equal to the antiderivative of the function dx. So make sure you've got both symbols there. So now just be careful about integrating. Again, making sure we've got the powers on everything. Add 1 to the power 3, divide by the power. So the 3's cancel, give you with 1/8. Add 1 to the power, what's that, positive a half, divide by a half. So 10 divided by a half is 20. So be careful. And x to the half is just root x. And the antiderivative of 1 is just x, plus some constant c. So let's substitute our initial condition at x equal to 4, y is equal to 25. So we're going to put that in. 25 out the front, substitute 4 in. So 4 cubed is 64. The square root of 4 is 2 plus 4. Add them up. Get them all on the one side. We end up with c is equal to 53. So rewrite your function as your answer. So it's really clear what your final answer is. All right, so state the smallest positive value of k such that x equal to 3 pi and 4 is a solution to that function. So I want to solve, we need x has to equal 3 pi and 4, so tan of 3 pi and 4 is in fact -1. So we're really solving cos kx equal to -1, which means cos kx, x is equal to 3 pi and 4, remember? So that's where the 3 pi and 4. So k 3 pi on 4 is equal to -pi pi 3 pi. So multiply by 4 and divide by 3. And also cancel off our pi's. We get negative 4/3, 4/3, and 4. The smallest positive value, 4/3. Yeah. All right, sine squared plus 3 sine x minus 2. So we've got to really see something like that, and it's got to hopefully yell out quadratic to you. So if I just put u equal to sine x, it's the same as 2u squared plus 3u minus 2. A little bit of cross product in there gives me a 2u minus 1, a u plus 2. So u is equal to a half, or u is equal to negative 2. So if u is equal to negative 2, there's no solutions for that because sine is restricted between negative 1 and 1, as a range that is. U equal to half means that sine x is equal to half, so x could equal pi on 6, 5 pi on 6, etc. We've only got the domain of 0 to 2 pi, so they're my two solutions. All right, make sure you address u equal to negative 2 and why there's no solutions from that branch. All right, so we've got a tan graph that we need to sketch. Y equals tan 2x plus 1. So first things first, I think, is, well, down here, let's highlight down the bottom. The period is pi on n, which in this case is pi on 2, which means my asymptotes are half of that. So my two asymptotes at negative pi on 4 and positive pi on 4. And my original graph, if I just draw that without any transformations, is just that, isn't it? So there's my original. And so everything's moved up 1 unit, which is why that intercept is now going through 1. So I want to find some x-intercepts, if I've got any. So tan 2x on the bottom right side is equal to negative 1. So 2x has to equal negative pi on 4 or 3 pi on 4. Divide by 2, we get negative pi on 8 and 3 pi on 8. So there's my negative pi on 8, and the period is pi on 2. So exactly pi on 2 units later, I get my next intercept at 3 pi on 8. I'm sketching it between negative pi on 2 and pi on 2. So I want to substitute in the endpoints to get values. So tan of 2 pi on 2 plus 1 is tan of pi plus 1. And tan of pi is 0 plus 1 is 1. So that's why I get pi on 2, 1 and negative pi on 2, 1. So hopefully, you know, I think this sort of, it's not the most complex trig function that we have to sketch. But y-intercept, of course, put x equal to 0. So let's read it. Sketch the graph. Label any asymptotes with their appropriate equation. We've done that. X equals x equals. And label the endpoints and the axis with their coordinates. We've done that. Ooh, axis intercepts. I didn't put 0, 1, did I? 0, 1 for the y-intercept. That may have cost me. Function between negative pi on 8 and pi on 8. I'm just going to do it there in blue. And you can see that the graph is symmetrical about the center axis. Yeah, and so the average value of that function is just going to be the middle point of those two endpoints, which is at 1. So I guess technically, question 5, use features of the graph in part B to find the average value of f between x equal to negative pi on 8 and as x is equal to pi. If we go back and look at the graph of speaking, especially for 1 point, the average value we can get from using the features of the graph is just to note that the average value is going to be the center of that little domain, given that the graph is symmetrical, which is at x equal to 1. Obviously, we can use the formula to get the average value of the function, and we still get 1. But to be honest, I'd need to check the examiner's report to see whether or not you got the marks for that, okay, because we didn't necessarily use the features. Okay, so that will be interesting to check. Bit of probability, arrival times of a train, the random variable x represents the number of minutes after the time that the train arrives. So a -1 means it's 1 minute early, 0 means it's on time, 1 is 1 minute late, 2 is 2 minutes late. Distribution is given below. Find the value of P. Well, we know that each of these values have to add up to 1. So 0.1, 0.4, 0.3 is 0.8. So the last one there has to be 0.2. Expected value of x is x times P of x. So -1 times 0.1 is 1, -0.1, 0 times 0.4 is 0, 1 times 0.3 is 0.3, 2 times 0.2 is 0.4, which gives me an expected value of 0.6. The variance, e of x squared times e of x all squared. So again, it's sort of -1 squared times 0.1. That's 1 squared. 4 is 2 squared. Multiplying the probability. So variance of x is e of x all squared, which was 1.2, minus e of x squared, which is 0.6 squared, which is 0.36. And that calculation is not beyond us. Passenger catches a train at the station on 5 separate occasions. What is the probability that the train arrives before the scheduled time on exactly 4 of these? So 5 separate occasions, so I have n is equal to 5. Okay, I want 4 successes, and going off the table, the probability of being 1 minute early is 0.1. I prefer 1/10. I'm surprised I didn't write it as 1/10. So x is distributed binomially with a 5.1. There's 1 mark. Probability that x is equal to 4 is 5c, 4. 1/10 to the 4 times 9/10, which I think is easier. 1/10 to the 4 is 1 over 10 to the 4 times 9 on 10, which is equal to 9 on 100,000, which is 9 on 200,000. Sorry, 9 on 20,000. Okay, if we just simplify, and that's fine. If you want to muck it around with the decimal, you can go for your life. Well, that'd be 0.0045 or something like that. But no, I'll leave it as a fraction. It's clear cut. Okay, at a large sporting arena, there are a number of food outlets, including a cafe. The cafe employs 5 men and 4 women. 4 of these people are rostered at random to work each day. That P hat represents the proportion of men rostered to work on a particular day. So there's 9 people on the roster, isn't there? So if P hat is the proportion of men, so 4, there's 4 people rostered on. So if I've got 4 people rostered on, the proportion of people that can be men, I can have 0 out of 4, 1 out of 4, 2 out of 4, 3 out of 4, or 4 out of 4 can be men. Okay, we have 5 men in total, so it could be all men. So they're the possible values of P hat. Find the probability that P hat is equal to 0. So I think the easiest way is the proportion that P hat is 0 is the same as having 0 men. Yeah, so 0 men means all women. So that's what we've got there. 4/9, 1 less woman, 1 less person. 3/8, 1 less woman, 1 less person. 1 less woman, 1 less person. And so then the easiest way is just to sort of, well, 4 goes into 4, 8 goes into 8. Sorry, 4 goes into 8. 3 goes into 1. 3 goes into 9 3 times. Just do a bit of simplifying. 2 goes into 1. 2 goes into 6 3 times. So what does that left me with? That left me with 1 on the top and 3. I think we've got a 2 there, haven't we? 3 by 2 is 6 by 7 is 42 times 3 is 126, which is where that comes from. All right, so there are over 80,000 spectators at a sporting match in the arena. 5 in 9 of these spectators support the Goannas team. A simple random sample of 2,000 spectators is selected. What is the standard deviation of the distribution P hat? The sample proportion of spectators support the Goannas team. Okay, so P hat is the proportion of people in the population, which is 5 in 9. We're told that. So P hat is 5/9. And the rule for the standard deviation is the square root of P hat times 1 minus P hat over N, which is where each of these values come from. 5/9 times 4/9 over 2,000, which is the size of the sample. So 5 on 40 times 9 on 9 is my 20 on 81 times 1 over 2000. So you can see there the 20 cancels out. We can turn that into 100 on the bottom. So 1 over 81 times 100. What have I done there? Why have I got 90 there? I think that's a little error there. So that should be 20 over 81. So 20, so let's come over here. 20 on 81 times 1 over 2000. So let's cancel the 2000. 20 goes the 20, so that leaves me 1 on 81 times 1 over 100 square rooted, yeah? So if I take the individual square roots, I get 1 over 9 times 1 over 10, which is 190. So fortunately, it's all about the final mark. So I got the mark still, but I'm not convinced about that little line there. I think I was just not sure what I was thinking there. It should be, I think in my head I was thinking of it, 81 is 9. All right, hopefully along okay. So find the composite function g of f of x. So substitute f of x into g of x, where g is 4 minus 2x. So there's my 4 minus 2x, expand and group things, 2 minus 4x cubed. Find f of g of x now, the opposite, and express it in that form. So now I'm going to substitute g of x, 4 minus 2x, into x cubed. So 2x cubed plus 1, and they want us to write it as a 1 minus 2. So we're going to take the 2 out as a common factor. Okay, so notice how at this point in time, everything is still cubed. So negative 2 cubed in here is negative 8 times 2 is the negative 16. And now I've just got x minus 2 all cubed plus 1, which is the same as 1 minus 16, x minus 2 all cubed, which is the format that I need. We don't need to worry about, they didn't ask me, I know a lot of the times we say m equals, k equals, d equals. Not requested, so don't do it. Because if you do it and you get it wrong because you just do something silly, you lose your mark. All right, the transformation with the rule, let's get to a better colour. The transformation of the rule given by Blur maps the graph of y equals g of f of x onto the graph of y equals f of g of x. Find the values of. Okay, so first things first, we've got our x dashed here. X dash is equal to x plus b. Y dash is equal to ay plus c. Rearrange that. I'll get x is equal to x dash minus b. Y is equal to y dash minus c on a. Now, I'm going to transform g of f of x, which is I want to transform 2 minus 4x cubed into something. So that's what I'm going to start with, yeah? Which is what I've got here. Might just do the highlighter. So there's my y equals 2 minus 4x cubed, and I'm going to substitute that in for y, that in for x. So there's my x dash minus b for x, and there's my y dash minus c on a for y. Rearrange a little bit, multiply the a across, y dash minus c equals 2a minus 4a x minus b all cubed, and then add c, so I get y equals 2a plus c minus 4a x minus b all cubed. So that has to be equal to, over here, just above it in yellow, 1 minus 16 x minus 2 all cubed. So clearly from that, hopefully we can see that b has to equal 2. The x minus b cubed equates to the x minus b cubed, or x minus 2. Negative 4a out the front has to equal negative 16. So then a is equal to 4. And so and then the 2a plus c has to be the same as 1. So we can get a series of little equations there. which is what each of these are, equating coefficients. And there's our values. This time we did have to state the values of A, B, and C, so clearly state them. The rule for the function given by f of x equal to that is defined on its maximal domain. Find the domain and the rule of the inverse function. Okay, so first things first, if we just get the function f of x, y equal to 2x plus 3 minus 1, swap the x and the y over, take the 1 across, square it, 2y plus 3, transform to get y equal to subject. I end up with y is equal to a half of x plus 1 all squared minus 3 on 2, which means the inverse function, no marks with that previous line, the inverse function is equal to half of x plus 1 all squared minus 3 on 2. Now, what's the domain and range? So the range for my original function, find the domain and the rule for the inverse function. The range for my original function, this graph here of f of x, is just translated sort of 3 units left, maybe 1 unit down. So maybe at x equal to 0, we don't get anything nice. So maybe it looks a bit like that. Yeah. There's my range there, which is -1 to infinity, and that's the domain of the inverse. All right. Solve f of x equal to f dash of x. You could try the square root equal to the square, but it's just so much easier solving one of them equal to x. So I've gone for the parabola equal to x this time. In fact, let's do it the other way. So what if I decided to do, let's solve x equal to the square root of 2x plus 3 minus 1. So take x plus 1 equals square root of 2x plus 3, square it. So it's pretty similar, isn't it? Expand it. It's nice, the 2x's cancel. So I get x squared equal to 2, x equals plus or minus the square root of 2. So any domain restrictions here? Yes, the domain of f inverse is from -1 to infinity. Therefore, x equals positive root 2 is the only solution because negative root 2 is not in the domain. All right, so either option works. Geez, there was 4 pretty good marks. First, we picked that up more easily because we had to restrict from the previous question one of our solutions here, and we did the same thing here. We got some solutions and we had to eliminate one. Okay, let G such that D maps onto R. G of x is 2x plus C minus 1, where D is a maximal domain. Find what values of C does G of x have no real solutions. Oh, there you go. So I've used the same method here, except it's in terms of C, isn't it? So I've got x squared. What happened there? Oh, there's a plus 1 there. Must have got rubbed out. So then the 2x's cancel. So I get x squared plus 1 minus c is equal to 0. So x squared is equal to c minus 1. So I now know for no real solutions, well, hang on. So to get solutions, c minus 1 has to be greater than 0, which means c has to be greater than or equal to 1. So if I don't have that, so probably a better way to think of it was need c minus 1 to be less than 0 for no solutions, real solutions. So then c has to be less than 1, which is what we've got there. For what values of c have exactly one real solution? Okay, well, for one real solution, the c minus 1 has to equal 0. Well, let's have a think about that. C minus 1 has to equal to 0, which is true, and we get c is equal to 1. Now, if we go back to that previous question, remember how negative root 2 wasn't a solution? because it was outside the domain. So since the domain for the inverse function is from -1 to infinity, we then need the solution to plus or minus the square root of c minus 1 to be an element of that -1 to infinity. Yeah. So in other words, if the magnitude of c minus 1 is bigger than 1, right, it'll take it outside the domain. So in other words, so let's think about that. If I just say c is equal to 3, right, even if I come over here, if I say c is equal to 3, I get x squared is equal to 3 minus 1, x squared is equal to 2, x equals plus or minus the square root of 2. It has two solutions, but x equal to -2 is outside the domain, so it goes back to having one solution. So all of a sudden, even though I get two physical answers, I only get one solution because of the domain restriction, yeah, which is why we get a second branch, right? And that's why it's question 2, and we had to use that logic through to help. That's it. Hope it went well.